Okay, so today I'll be presenting on properties and uses of plastics as a construction and engineering material. So first of all, what is plastic? A plastic is a material that is made of a wide range of synthetic or semi-synthetic organic compounds that can change its shape. Many things are made of plastics, usually because making them to the right shape is easy. What are the properties of plastics? The general properties of plastics are appearance. There are so many types of models of plastics available, such as transparent, colored, etc. Suitable pigments are added in the process of manufacturing of plastic material to get these different properties. As you can see in the pictures below, that these properties are very important because they are what will give the good appearance to the structure and make it attractive. Thermal property. The thermal conductivity of plastics is very low and is similar to wood. The thermal insulating capacity of plastics is rated by measuring the thermal conductivity. Thermal conduction is basically the transfer of heat from one part of a body to another with which it is in contact. And here you can see some pictures of foam that would be used for insulation. Electrical property. Plastics are good electric insulators, and this is because they have high dielectric strength. Dielectric strength is an indication of the electrical strength of a plastic as an insulator. And as you can see here in the pictures below, that the jacket and the insulation of the cable is made out of PVC. Chemical resistance. Plastics offer great resistance against chemicals and solvents. Most of the plastics available offer great corrosion resistance, which is why plastics are replacing corrosive metals in the case of water carrying pipes. Melting point. Generally, plastics have a very low melting point. Some plastics may melt at just 50 degrees Celsius, so they cannot be used in the positions of high temperature. Thermosetting type of plastics have a higher melting point than thermoplastics. However, thermosetting types cannot be used for recycling. So in order to improve the heat resistance of the plastics, glass fiber reinforcement is provided in its structure. Durability. Plastics with sufficient surface hardness have good durability. Sometimes plastics may be affected by termites and rodents, especially in the case of thermoplastic types. However, this is not a serious problem because, unlike wood, plastic doesn't contain any nutrition values. And like I mentioned before, plastic is corrosion resistant. Therefore, this makes it even more durable. Ductility. Ductile nature of plastic is very low. When tensile stress are acting on plastic member, they may fail without any prior indication. And as you can see here on the picture on the left, you can see the ductile fracture, and you can also see a brittle fracture. And here you can see a plastic under tensile stress, and the reaction is a ductile fracture, as you can see here. Fire resistance. The resistance to temperature or fire for varieties of plastics considerably varies depending upon the structure. In order to suppress or delay combustion, retardant plastic additives are added to plastics, and these compounds are usually in impending burning in the ignition phase of fire, but they do not prevent charring or melting, nor do they increase the heat resistance. Plastics made of cellulose acetate are burnt slowly. PVC made plastics do not catch fire easily. Plastics made of phenylformaldehyde and uraformaldehyde are fireproof materials. As you can see in the picture below, there are pieces of PVC lit on fire, and it takes long to catch fire, but even after PVC catches fire, the fire doesn't spread. It stays in the same area until the piece melts. As you can see here, it's only in this area, it doesn't spread to the rest of the PVC. Sound absorption. By the saturation of phenolic resins, we can produce acoustic boards. These acoustic boards are sound absorbents and provide sound insulation. This is because plastics can simply absorb sound by transforming it mostly into heat. These types of acoustic ceilings are used generally for theaters and seminar halls. And here are some pictures of the acoustic boards being used for ceilings. Optical property. There are so many types of plastics. Some plastics are transparent, which allows light in its original direction, and some are translucent, nothing but semi-transparent, which allows light but changes light rays direction. And here on the left you have a picture of a plastic window which is transparent, and on the right you have plastic which is translucent. Recycling plastics. Disposal of plastics in the environment causes severe pollution, but it is not a serious problem because of its recycling property. We can use plastic waste disposal conveniently to produce drainage pipes, fencing, handrails, carpets, benches, etc. And here we have a picture of the drainage pipes which were made from recycled plastics, as well as a bench. Weather resistance. Most of the plastics, except some limited varieties, are capable of resistance against weathering, but major problem is when the plastics are exposed to sunlight. They are seriously affected by ultraviolet rays and get brittle. To prevent this, plastics are incorporated by fillers and pigments which helps to absorb or reflect the UV rays to the surface. And here on the left you can see I have a picture of plastic being used for roof covering, and on the right is a picture of your roof covering after it was exposed to UV rays. Humidity. The plastics made up of cellulosic materials are affected by the presence of moisture. This is because water in the air permeates into the material or forms a water film on the plastic surface. Thus, this reduces the plastic performance. The plastics made of polyvinyl chloride offers great resistance against moisture. And here in the picture you can see the greenhouse was made using plastic. Maintenance. They don't need any surface finishings because the plastic already comes with its aesthetic appearance. That's why maintenance of plastics are so simple, because they don't need any surface finishing coats or paints. And the weight of plastics. The plastics have a low specific gravity, generally ranges from 1.3 to 1.4, so they are light in weight and easily transportable to any place in a large quantity. The uses of plastics in construction. For walls. Structural insulated panels are used for walls as well as floors and roofs for residential and light commercial buildings. Structural insulated panels are high performance building panels. The panels are made by sandwiching a core of rigid foam plastic insulation between two structural facings such as oriented strand board. And here I have a picture illustrating the exterior and interior sheetings as well as the foam core. And the right they have a picture of the structural insulated panels being used as a wall in construction. Flooring. Plastic flooring is a versatile flooring option that can be used for many specialty and home installations. Plastic materials like polyvinyl chloride and polyethylene are used to make flooring less prone to wear and tear. It also decreases the sound pollution level and can be cleaned easily. Plastic flooring is available in hard tiles intended to handle heavy loads and soft and flexible materials intended for garage and basement tiles as well as fitness or athletic areas. And here you can see I have a picture of a floor made from plastic for a residential home and as well as a floor made for an athletic area, which in this case is a basketball court. Windows. Polycarbonate windows are considered more burglar proof than regular glass windows, and this is because polycarbonate is actually 200 times stronger than glass and will not shatter, and it is also lighter, easier to install, and less expensive than glass. Therefore, it is an excellent alternative to traditional glazing. Two plastic materials, vinyl and fiberglass, are used commonly in the production of window frames. Fiberglass is extremely strong while vinyl is quite durable and also inexpensive. And here you can see a picture of a plastic window. Doors. Some construction projects use doors made from a stiff polyurethane foam core with a fiber reinforced plastic coating. The sandwich structure of these doors makes them incredibly strong, and apart from being strong, polyurethane is also easy to clean. And here is just a picture of what the doors look like. Roofing. To protect the outer surface of the roof from damage, two layers of different plastic materials are required. The upper part is made of colored thermoplastic olefin, vinyl, or polycarbonate. Polycarbonate is a very strong and resilient thermoplastic material, and it is also frequently used for roofing on industrial warehouses, while the lower part consists of polyurethane foam, which consumes less energy and keeps the interior of a house cooler. Here you can see how it is used as a roofing material. Insulation. Rigid polyurethane foam is known for its high thermal resistance, which promotes temperature consistency. Polyurethane foam is also popular because it is lightweight, chemical resistant, and flame retardant. Due to its closed cell nature, polyurethane insulation performs as an air barrier, resulting in significant energy savings. And here is a picture illustrating how the The foam is sprayed onto the wall for insulation. Pipes, commonly made up of polyvinyl chloride, CPVC, ABS, or polyethylene, plastic pipes are flexible and very light in weight, making them easy to install. All of these plastic materials are also highly chemical and water resistant, making them suitable for many extreme environments. Due to these properties, it is replacing metal pipes in the case of plumbing. Here you can see the PVC pipes, and as you can also see them being used for plumbing in a building. And now I'll play a short video about plastics.
Your home is your castle, and its cornerstone is chemistry. Chemistry makes your home and every building more comfortable, efficient, and attractive. Let's look at just some of the places where chemistry is at work in your house. Engineered wood products can be found inside and outside, in the floors, walls, and roof, as well as in kitchen cabinets and laminated countertops. Chemistry also is key to keeping your house warm in winter and cool in summer. Did you know that up to 40% of home heating and cooling costs can be lost through tiny cracks and holes? That's why caulks and foam insulations are made specifically to fill these irregular gaps. Meanwhile, silicones, polyurethanes, and acrylics help bond window frames to surfaces like wood, concrete, or aluminum. These sealants help reduce air leakage, keep indoor temperatures comfortable, and increase your home's energy efficiency. Anyone who's ever dealt with a burst water pipe knows the costly effects weather can have on building materials. But plastic pipes can withstand years of freezes and thaws. And thanks to multiple joining technologies, leaks and breaks are further limited. Plastic pipes also won't corrode, and they resist internal mineral buildup, so your water stays crystal clear and water flow stays strong. Plus, they're cost-effective and easy to install. Chemistry is also underfoot, enabling fun and functional possibilities for your carpet and floors. In bathrooms, entryways, and other high-traffic areas, vinyl tile is a long-lasting, easy-to-clean flooring option. Polyurethane-based top coats can enhance scratch resistance to extend floor life even longer. Carpets made from nylon or other fibers like polyester or polyolefins are great for families with young kids or pets because they're stain and moisture resistant. Soft polyurethane padding underneath makes carpets more comfortable. It also provides insulation against the cold and acts as a sound barrier for those of us with noisy kids upstairs. So you see, inside and out, top to bottom, the products of chemistry make your house a better place to come home to.
And that concludes my presentation. Thank you for listening.